3.3, dividing polynomials, remainder factor theorem. Let's get this party on the road.
Got a better idea this morning.
So, here we go. So, I'm going to show you what you should have learned in elementary that people are not taught anymore in elementary. And then we're going to throw the alphabet in there.
Huh? What? No. Let's not do that. No.
So, here we go. We have 3,471, and we're going to divide it by 7. So,
Or Kim won?
Short answer is 463. I don't know the decimals after.
Today.
So,
I felt it.
here we go.
Right? Am I correct?
What we want to do is figure out how many times 7 goes into 34,
A lot.
and it would be 4 times.
495.8.
And then you multiply 4 times 7 to get 28.
That's how I learned how to do long division.
And then from here you subtract.
Yeah.
Okay? So 28 minus, 34 minus 28. 6. Then you drop
Off the rails.
the next one. And so now you see how many times 7 goes into 67. So that would be what, 8 times? 9 times. 9 times. 9 times 7 is 63. And then we subtract.
4 and drop a 1 is 41.
You subtract and get 4. You drop down the 1, you get 41. Now you see how many times 7 goes into 41. That would be 5 times. 35. Subtract. And you get 6. Okay? Now, this is your remainder. That is your remainder right there. So what we did here, before you started doing, it was before you did the decimals, we wrote this as a mixed number. And so we had 495, and then we would add our remainder over what we divided by. We're going to do that same step, or same process, but with polynomial functions. So, that would be your answer. Technically, when you write a mixed number, there should be a plus sign in the middle, but we usually don't do that.
I'm about to say, I ain't never seen it done that.
So, here we go. Now, we have polynomials that we're going to divide.
I knew it.
It's the same exact process as before.
Straight up no.
Okay? So, here we go. One thing you need to make sure of is that these terms are in order. So you have an x cubed, an x squared, an x, and then a constant. Okay? And so when we do this, the thing that comes first is going to go inside. And then what you're dividing by goes on the outside.
Good to know the acronym still applies.
Okay?
You can't put this in the calculator.
No.
I didn't know this is the first time I've ever seen you can actually do this. Look, I'm scared.
So here we go. You're always trying to get this first term or whatever the first term is. So you have to think to yourself, what can we multiply 3x by to get 6x to the third power? Well, to get that would be a 2x squared. The exponent will go down because this right here is a 1. It will go down by 1 from what you started with. If this was a 2, then it would have gone down by 2. So this is our new thing. So what we're going to do is I have found it easier for some people to write this off to the side and show that you are multiplying the 2x squared times the 3x plus 4. So 2x squared times 3x is the 6x cubed. This first term, or whatever your first term is, should always be exactly the same. Exactly the same, identical. Then you take the 2x squared times 4. 2 times 4 is 8, so you get 8x squared. And everything should line up under its like term. Okay? And that's the process. Now the next thing is we subtract it. So what I do is I say draw the line, and we change all the signs, and I circle it so I know that I changed the signs. Okay, since I was born in the 1900s, my memory is bad. Okay, so I circle it so I remember that I changed the signs. Okay, that's the subtraction step. And so now you just subtract. So 6x cubed minus 6x cubed cancels out. That first term should cancel out. 17x squared minus 8x squared is 9x squared. And then you drop down the next term. And you repeat the whole process again. So now we're trying to get it to be identical to 9x squared. So 3x times something gives you 9x squared. That would be a 3x. So again, off to the side, if you need the visual, you're going to take 3x times 3x plus 4. So you have 3x times 3x gives you a 9x squared. 3x times 4 gives you 12x. Once you're here, draw your line, change all your signs. If it's positive, it becomes negative. If the sign was minus or negative, it becomes positive. You're changing it to its opposite sign. So from here, 9x squared minus 9x squared cancels out. 27x minus 12x is 15x. And then you drop down your next term.
This actually makes sense.
And then you repeat the process. So now you ask yourself, what can we multiply 3x by to get 15x? 5. So you do the same thing. And if you don't need to do this part off to the side, that's fine. It's just some people it makes more sense to see it this way. Some people it doesn't matter. Okay? So 5 times 3x is 15x. 5 times 4 is 20. Again, draw your line. Change all your signs. 15x minus 15x cancels. 20 minus 20 also cancels. So we're left with a remainder of 0, which means it divides evenly.
That makes sense.
So this would be your remainder, which it's 0, so that's a good thing. We're going to learn what it means in a little bit, what a remainder of 0 looks like. And so your answer comes from what's on top. So our answer that we would type in would be 2x to the second plus 3x plus 5. And so that would be the quotient when you divide. That is your final answer. Long division, this is long division, works 100% of the time. I'm going to show you another method that only works in certain instances, but it is quicker.
Yay, more mental. But wait, there's more.
There's always more.
This is like the crappiest infomercial ever.
Okay, now we are going to do another one. So we're going to repeat the same process. So I wrote it in a different format. So this one used the division symbol. This one is in the fraction, which just means to divide. So same concept. The top, the numerator, is going to go on the inside. The denominator is going to go on the outside. And you do the exact same process. So, we ask yourself, what do we need to multiply 2x by to get 4x squared? And that would be a 2x. So again, off to the side, we're going to multiply it out to show our distributing. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. From here, draw your line. Change all your signs to the opposite. So now this sign changed to a positive. So 4x squared minus 4x squared cancels. Negative 8x plus 2x is a negative 4x.
Huh?
Not a negative 4, sorry, negative 6.
I was gonna say.
And then you drop down the 6. And you repeat the process again. So now you ask yourself, what do we multiply 2x by to get a negative 6x? Negative 3. Because we want it to be the exact same. So, over here off to the side, negative 3 times 2x minus 1. Negative 3 times 2x is negative 6x. Negative 3 times negative 1,
Three.
positive 3. Here we go. Draw your line. Change all your signs. Negative 6x plus 6x cancels. 6 minus 3 is 3. So now this time we have a remainder. So when you have your remainder, you're just going to add it to your answer in the form of a fraction. It's going to be your remainder over what you were dividing by, just like every other fraction or every other division problem. So we have 2x minus 1 plus our remainder over what we divided by.
2x minus 3.
Oh, thank you.
It's the memory, dude.
It's the memory. It's the old age.
But it's written right there.
Omega 3.
I'm blind.
Omega 3s.
I'm blind too.
Oh, I can't help with that.
I mean, without my glasses, I can't read that from here, so.
So, there we go. Boom. Okay. So it's same process over and over. So that is long division. Now, they may ask this in different forms where they want you to write your answers in different ways, but it's the same process every single time. Usually the only difference is how you write your remainder depending on what it's asking. And so that leads us to this division algorithm, which is kind of goofy.
Yes.
Okay. So basically what this is wanting you to do is it's wanting you to write your quotient for Q of X, and then R of X is just your remainder, and that's it. Again, I just teach here. So,
Oh, God, something.
everything is the exact same process when it comes down to this. So, when we go to do this one, okay, notice that we have an x to the fourth. Let me zoom in. X to the fourth, x to the third, and then an x squared. It's missing some terms. So we're going to add in some placeholders. We're going to add in a 0x and a 0. It's not going to make much of a difference here, but when we do the synthetic division, it does make a difference. So I just like to be consistent in just adding it in so we can see. Again, you want to make sure that these exponents are in numerical order descending. So 4, 3, 2, 1, none. Okay. And then this term right here, notice that it goes x squared and then a constant. So it's missing that x term. So again, I like to add in a placeholder. It is not super required here, but I just like to have it there to keep it all consistent. Just adding in that placeholder so I know that I'm not messing up. So here we go. We're going to take the numerator and put it on the inside. We're going to take our denominator, put it on the outside. And then we can go through our long division steps. So 3x squared times something gives us 18x to the 4th. That would be a 6x to the 2nd. So off to the side, we're going to multiply. Six x squared times 3x squared is 18x to the 4th. 16x squared times 0x is just 0. 16x squared times 1, or 6x squared times 1 is a 6x squared. So this is why I put the 0 there, so I know that I'll have a space, and I'm making sure that I line up the like terms. So if you can do that without adding the 0, that's fine. You don't have to add the 0. So from here, draw the line, change all the signs to the opposite. 18x to the 4th minus 18x to the 4th cancels out. 9x to the 3rd minus 0 is just a 9x to the 3rd. 3x squared minus 6x squared is a negative 3x squared. And then if you want to drop down the 0x, you can. And then we go through the exact same process. So we ask ourselves, what do we need to multiply 3x squared by to get 9x cubed? And yes, 3x. So we have 3x times 3x squared plus 0x plus 1, and we distribute. 3x times 3x squared is 9x cubed. 3x times 0x is just 0. And 3x times 1 is 3x. From here, draw your line, change all the signs. Nine x cubed minus 9x cubed cancels out. Negative 3x squared minus 0 is still just a negative 3x squared. 0x minus 3x is a negative 3x. And then if you want to drop down that last 0, you can. You won't necessarily need it. Oh yeah, you will. Okay. So repeat the process again. This will be our last time. So once you get to a point where this variable matches what you're dividing by, that's how you know you're near the end. This will be the last time we find a number to multiply by, and then we have our answer and our remainder. Okay, so 3x squared, we want to get negative 3x squared. So we just need to multiply by -1. So if you can do that without showing the step, that's fine. Again, I just like to try to be consistent. So -1 times 3x squared is a negative 3x squared. -1 times 0 is just 0. -1 times 1 is a -1. From here, draw your line. Change all your signs. So they were all minus signs. They all changed to the opposite, which is positive signs. Negative 3x squared plus 3x squared cancels out. Negative 3x plus 0 is a negative 3x. 0 plus 1 is a plus 1. So now this time your remainder is an expression, which can happen. So on this type of problem, when it says find Q and R, Q is going to come, or Q of X is going to be the quotient on the top. R of X is going to be your remainder, like that. And so you will have two separate boxes where you type your answers in, just like that. The Q of X and the R of X should already be there. So that is long division. I have people that love long division, prefer long division, always do long division. It will work 100% of the time. The next part is what's considered the shortcut, but it only works in certain cases. Okay, so synthetic division, again, is the shortcut.
That just sounds easy.
In order to use this, you have to be dividing by something that's in the form of x plus or minus a number. Okay, x plus or minus a number. And then if you're missing anything, you have to put a placeholder of 0 in its spot. Okay, so everything we've done up until this point, you cannot use synthetic division. Okay, because here we're dividing by a quadratic, which doesn't work. This example, it's not in the form of x plus or minus a number because it has a 2 in front, and that makes it overly complicated, so we just don't even worry about it. And then same thing here, there's a number in front of the x, so you cannot use synthetic division. Okay? Now, if it comes down to it and you don't like synthetic division, that's fine, but it is a quicker method for what we're going to do Monday of next week. Okay? So, here we go. We're going to use synthetic division to determine Q of X and R of X. Okay, so what we have to make sure of is that we have all of our terms and we're not missing anything. And if you look, we go x to the 5th, x to the 4th, and then we jump to an x squared. We're missing that 0 or that x cubed term. So we're going to plug in right there a 0x to the 3rd. In between the x to the 4th and the x to the 2nd. Then we have our x to the 1st, then we have our constant, so we're good. Okay? We're dividing by something that's in the form of x minus something or x plus something, so we're good there. And so now is the setup. Okay? So, first thing we're going to do is we're going to take what we're dividing by and we're going to solve for x. So to solve for x, we just add 2 to both sides. And we get x equals 2. Okay, so with our setup, I don't know formal words. I call this the half box because it's half a box. Okay, that number that we just solved for, we're going to place in that half box. Then we're going to list out the coefficients and the constants from every single term. So basically all that means is we're taking just the numbers with the signs included and we're going to list them out here with a little bit of space in between. Okay, so we have 6, -2, our placeholder, 4, -3, and 1. So again, all of those came from in front of your X's with the sign in front of it included. All of those numbers. And we put them in the order. Okay, so as their exponents are descending, that's the order they go in. From here, you're going to leave some space and you're going to draw a line. Okay, so anything that is above the line is going to be added together. So you're going to have stuff here that's going to be added. Those all right in here are going to be added together. Okay. Anything that's below the line gets multiplied by the 2.5 box. So above the line we add, below the line we multiply. I'm not going to put that, I'm going to put it as an X. I didn't want to, but yeah. We multiply. Add, multiply. Okay, and it's going to go in a zigzag pattern. Zigzag pattern. So it's going to look like this and then zigzag. Down and across. Down and across. Down. And you're just going to keep going until you run out of numbers. Makes a zigzag. So here we go. The first term, always, no matter what, gets dropped down. Always. And now we're going to multiply 2 times 6. That gives us 12, and it goes diagonally above the line. So down and cross. These two are above the line, so they're going to be added. -2 plus 12 is 10. Now it's below the line, so we multiply. 2 times 10, we get 20. Again, it goes diagonally. It's above, so we're going to add these two terms together. 0 plus 20 is 20. Now it's below the line, so we're going to take 2 times 20, we get 40. Again, that zigzag pattern. Now we're going to add these two terms. So 4 plus 40 is 44. It's below the line, so now we multiply. 2 times 44, 88. Now we're going to add these two terms. -3 plus 88 is 85. Then we're going to multiply 2 times 85, 170. And then it's above, so we add and get 171. So I'm going to run through it now that you see the numbers and you can kind of see the pattern. Okay? You're going to drop down the first one. You multiply by 2, the answer goes diagonally. You add straight down, and that's how you get this new number. Then you multiply diagonally. Everything, anytime you're multiplying by the 2 up in the half box. You add down, you get a new number. You take that, multiply by 2, answer goes diagonally. You add down, you get a new number. Multiply by 2, answer goes diagonally. Add down, you get a new number. Multiply by 2, answer goes diagonally. And then add down, and you're done. Once you run out of numbers, you're done. Okay? Now, how do we get our answer from this? I like to start with my remainder. The remainder will always be the last number. And then you work your way up. Next to the remainder is always the x term. The constant. So 85 is going to be my constant. That's going to be the only term without a variable next to it. Next to the constant is the x term. Next to the x term is the x squared term. Next to the x squared is x cubed. Next to x cubed is x to the 4th. Your final answer should be 1 degree less than what you started with. We started with an x to the 5th. My answer is going to be an x to the 4th, so it's 1 degree less. So what we found are the coefficients. So your answer is 6x to the 4th plus 10x to the 3rd plus 20x to the 2nd plus 44x plus 85 plus your pause. It said Q and R. That's your answer. That's your Q of X answer. So let me write Q of X in front of it. I forgot that it wanted that. Your remainder, R of X, is just 171. Now, if this is the first time you've seen this, I expect it to be a little bit confusing. Okay? Practice makes progress. Okay? So, again, this is the method that I'm going to use on Monday because it's quicker to do what we're going to need from it. But again, when it comes down to it, I don't care how you divide as long as you can divide. If you prefer long division, that's cool, as long as you can do one of the methods.
That's the second time you said my man scared.
Well, no, because it just involves this. Monday's not after spring break.
No, the week after.
Oh,
The spring break.
yes.
So after Monday, you got the week to dwell on it.
Yes.
You know,
Okay, here we go. Let's do another one. Okay. So we have 3x squared plus 7x minus 20 divided by x plus 5. We have our x squared. We have our x to the 1st. We have our constant. It's in order. That checks out. This is a linear term right here. Okay, in the form of x plus or minus a number. So we take what's in the denominator. We set it equal to 0. We solve for x. This time we're going to subtract 5 from both sides. We get x equals negative 5. So that is the number that's going to go in our half box. We're going to list out our coefficients. 3, 7, and negative 20. 3, 7, and negative 20. 20. Leave a little bit of space and draw a line. And then we repeat the same synthetic. Down and diagonal, down and diagonal. Okay? Anything above, we add. Anything below, we multiply by -5. First term always gets dropped down. We multiply. -5 times 3. -15. And it goes diagonally. Now you add.
-8.
7 plus -15 is a -8. It's below. So now we're going to take 5 times -8. That answer goes over here. That's positive 40. And then you add down -20 plus 40. And that's a positive 20. The last number is always your remainder. Your constant, your x. So, for the answer, it wants it in that q of x form, q of x, r of x. So your q of x is 3x minus 8. Your r of x is 20.
That's not so.
Okay? So, now, there's a remainder theorem that you can use that says basically if you perform synthetic division, your remainder would be the same thing if you just plugged in the number for every single x. Okay? And so for some people that's helpful because order of operations messes us up. Sometimes people rather just plug in a number, and again, that's fine. It's all about just different tools, and then you can decide the route you want to approach. So that's what this is saying in simpler terms. Okay. If we're dividing by x minus c and the remainder equals f of c, okay, so if you just plug in that same number that we solved for x, you're going to get the remainder either way. So I'm going to show you both ways. That way you can decide what you prefer. Okay. That way you at least see it. Okay. Now, if you saw find f of -2 in previous classes that we had, we would just take f of -2 and we would go through and plug in -2 for every single x. Okay? The problem that I see people have is order of operations. I see a lot of people multiplying 4 times -2 first and then cubing it. And then 5 times -2 and then squaring it. Which is why my high school students get these problems wrong. Okay? So, if we were going this route, you would take 4 times -2 to the third power is -2 times -2 times -2, which is -8. Plus 5 times -2 squared. So -2 squared is -2 times -2, which is a positive 4. Then we have -6 times -2. That is a positive 12. And then I'm just going to drop down that 4. So from here, we can multiply 4 times -8, get -32. 5 times 4 is 20. And then I'm going to go ahead and add these two terms, 12, or subtract them. 12 minus 4 is 8. Okay. From here, I would get 28 plus a -32, or 28 minus 32, or -32 plus 28, however you want to see it. The answer should be -4. That's what we've done in previous sections. Okay? That's not new. Now, when it comes to adding and subtracting, it really doesn't matter the order in which you add and subtract, as long as you keep what's positive, positive, what's minus, minus. Okay? So, you can do the same process, but with synthetic division, in hopes that you just, or where the remainder is going to be -4. And if it's not -4, then we messed up somewhere, and it's okay. So, here we go. So, this time in the half box is going to be that -2. Our coefficients we're listing out are 4, 5, -6, and -4. Again, they're in order 3, 2, 1, and none. Leave a little bit of space. Above gets added, below gets multiplied. First term always gets dropped down. Multiply. -2 times 4, -8. 5 plus -8, -3. -2 times -3, 6. -6 plus 6, 0. -2 times 0, 0. And -4 plus 0 is -4. You have your remainder. Oh my goodness. And your remainder is the answer to the problem. So, with the synthetic division, the numbers were a little bit smaller to work with. That's not always the case, but in this case it was. Versus all of that. Again, either way you go, you get the same answer. I don't care how you approach it, as long as when you see f of -2, you can tell me the answer. Okay? But you have two different ways. This is what we've learned in like one of the first sections, and this is the same thing using synthetic division. Okay? Next part. Last part. Woohoo. This is what's going to come up on Monday. I'll mention it again. Okay? So, on last Monday, we talked about factoring to find the zero so we could graph with the end behavior and all that other stuff. Okay? This is used when you can't factor necessarily. Okay? And so when you get a remainder of 0, that means you have found a factor of the polynomial. Okay? When you get a remainder of anything else that's not 0, then it's not a factor, which means it's not an x-intercept, a root, a solution. It's not crossing the x-axis at that value. Okay? And so that's all the factor theorem is saying, is that if f of c is equal to 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c equals 0. That says the exact same thing twice in two different ways. Okay? So, on this one, we want to solve the equation given that -2 is a 0. This right here is telling us our starting point. That is one of our solutions. We have to find the other two. The reason there's 2 is because this is an x to the third power, and so we can have up to 3 different solutions, and right now we know one of them. So there's 2 possible ones left. So, what we do is synthetic division. This is already solved for us, so this right now is x equals -2. Factored form would be x plus 2. So that's the factored form of this. Okay, when we were dividing, that's what we would be dividing by, and then we solved that and got x equals -2. This tells me I'm spelling stuff wrong all the time. Okay, so here we go. Synthetic division, some factoring, and then we're done. -2. Make sure you're not missing anything and your terms are in order. So 3, 2, 1, none. So we're good. We list out the coefficients. 2, -3, -11, +6. Leave a little bit of space. First term gets dropped down. We multiply -2 times 2. We get -4. When it's above, we add. When it's below, we multiply. -3 plus -4, -7. -2 times -7 is a +14. -11 plus 14 is 3. -2 times 3, -6. 6 minus 6, or 6 plus a -6, is 0. So we have a remainder of 0. We have our constant, our x, and our x squared term. And we're left with this. Now, we started with something that we couldn't factor. Now, we're down to something that can be factored. So this is factorable. So now all we have to do is factor this to find our other two zeros. Okay? Now, this is technically, to make it equivalent, this is technically still being multiplied by that factored form of x plus 2. That way, this is equivalent to what we started with. Okay, so our answer times that factor is what we started with. Really, we already know this answer, what that's going to be. So we're just going to focus on this piece right here. So to factor that piece, this is the slide and divide method. Slide and divide that we did in P.5. Okay, so slide and divide, we take the first term times the last term to get us a new polynomial to work with. And 2 times 3 is 6. So from here, if you like to use the x to organize your thinking, that's the only purpose of it. Other than that, there's no purpose to it. Last number goes on top. Middle number goes on bottom. We want to multiply to get +6, add to get -7. Multiply to get -6, add to get +6, add to get -7. That would be -6 and -1. So this factors into x minus 6 times x minus 1. Bless you. And now this was the slide. Now we have to do the divide, where we divide by that original number. So, if it simplifies, simplify it. 6 divided by 2 is 3. If it doesn't simplify, remember that goes directly in front of the x that it's with. And so that is 2x minus 1. And then I'm going to drop down that x plus 2. And now you just have to set each factor equal to 0 and solve so you can get your 3 different x values. Okay. If you can look at this and say x equals that, that's cool. That's fine. If you're there, you're there. If not, write it out. X minus 3 equals 0. 2x minus 1 equals 0. We already have this one solved for us, so I'm not going to solve. That was given to us. I'm going to write that. This was given. I don't want you to think I'm skipping it. So that's included in our answer. Okay. Here on the first one, we're going to add 3 to both sides. Get x equals 3. The next one, we're going to add 1. And divide by 2. And we get x equals 1/2. Sorry, I know that's at the bottom. Ooh. So we have our 3 solutions. Boom, boom. So when you write them out, solutions, we have x equals 3, 1/2, and -2. If it wants it in the factored form, that would be x minus 3, 2x minus 1, x plus 2. It may not ask for that, but I'd rather give that to you than not give it to you, and then y'all need it. Okay? So this process is going to be used a lot in Monday. The only difference is you won't be given that starting 0. You will have to find that first 0 and then go through the guess and check process to find the other zeros. Okay, but that is it for 3.3.